Hi everyone, myself Dr. P. Soumya, working as an assistant professor in the Department of Chemistry, Institute of Aeronautical Engineering College. In this session, I am going to discuss about types of hardness and units of hardness of water. So in this session, I am going to cover the topics what is soft water, what is hard water, types of hardness of water, units of hardness of water. So here the pure water is composed of two parts of hydrogen, one part of oxygen by volume and dissolves many substances. So the pure water it is consists of two parts of hydrogen and one part of oxygen. So the formula is H2O. So this dissolves many substances. So this is acts as very good solvent. So this is called as very good solvent and it is also called as universal solvent. The water is also called as universal solvent because it dissolves many substances. So here what is soft water? The water which does not contain dissolved salts of calcium plus 2 and magnesium plus 2 is called as soft water. The water which does not contain dissolved salts of calcium plus 2 and magnesium plus 2 is called as soft water. So here generally water consists of calcium salts and magnesium salts like calcium carbonate, calcium bicarbonate, calcium bicarbonate, calcium bicarbonate, calcium sulfate, calcium chloride, calcium sulfate and magnesium carbonate, magnesium bicarbonate, magnesium chloride and magnesium sulfate. So generally water contains dissolved salts of calcium and magnesium plus 2. So like calcium carbonate, calcium chloride, calcium bicarbonate and calcium sulfate and magnesium carbonate, magnesium chloride and magnesium sulfate. So the water which does not contain dissolved salts of calcium plus 2 and magnesium plus 2 is called as soft water. So this water, the water which can give lather with soap easily is called as soft water. So water which does not contain dissolved salts of calcium plus 2 and magnesium plus 2 and the water which can give lather with soap easily is called as soft water. Here the soap will contain sodium stearate. So sodium stearate. So this sodium stearate it will reacts with soft water. It will reacts with soft water and form sodium hydroxide and stearic acid. So when the soft water is treated with soap, the sodium stearate which is present in soap, it is reacted with soft water and forms sodium hydroxide and stearic acid. Stearic acid. So this stearic acid again reacted with sodium stearate, so which is present in soap and it will form lather. So here formation of lather takes place. So when sodium stearate which is present in soap is reacted with water, that is soft water which does not contain calcium plus 2 and magnesium plus 2. So this will form stearic acid. This stearic acid again treated with reacted with sodium stearate and it will form lather. So this is about soft water. Here what is hard water? The water contains dissolved salts of calcium plus 2 and magnesium plus 2. So the water contains dissolved salts of calcium plus 2 and magnesium plus 2. So examples calcium chloride, calcium sulfate, magnesium chloride, magnesium sulfate, and calcium and magnesium bicarbonates. So the water which is containing dissolved salts of calcium and magnesium plus 2 is called as hard water. So this cannot give lather with soap. The hard water cannot give lather with soap easily. So this water is called as hard water. So the water which cannot give lather with soap easily is called as hard water. Here in sodium stearate, so we are having sodium stearate in soap. So this is reacted with calcium plus 2 and magnesium plus 2 ions which are present in water, that is hard water. It will form calcium stearate. Calcium stearate plus 2Na plus ions. Plus 2Na plus ions. So the sodium stearate it will react with magnesium plus 2 ions and it will form magnesium stearate and sodium ions. So the water which is containing calcium plus 2 and magnesium plus 2 ions. So when these ions are treated with soap that is containing sodium stearate, and it will replaces the calcium plus 2 ions from the water and it will form sodium plus ions. So that's why this cannot give lather with soap. So here the minerals in hard water reacts with soap and form scum. So the interferes the soap's ability to lather. So the hard water interferes with soap's ability to lather. So more soap is needed to form lather, hence they are not suitable for washing. So when we use hard water for washing, here more soap is needed to form lather. So hence they are not, the hard water is not suitable for washing purposes. So when these are treated with soap, the hard water treated with soap, it will form insoluble salt or scum. It will form insoluble salt, insoluble salt or scum. So because of this, here this will the soap ability of soap is decreases because of the hard water. So the more soap is needed for the washing. So this hard water is not suitable for washing purposes. Types of hardness. This hardness in water is of two types. First one is temporary hardness. Second one is permanent hardness. Here, temporary hardness. The hardness that cannot be removed simply by boiling is called as temporary hardness. The hardness that cannot be removed simply by boiling. The hardness that can be removed simply by boiling is called the temporary hardness. So this hardness is removed by boiling. This hardness is removed by boiling. Simple boiling. So the temporary hardness can be removed simply by boiling, and here it is due to the presence of magnesium and calcium hydrogen carbonates. So when water is having magnesium hydrogen carbonate or magnesium bicarbonate, calcium hydrogen carbonate or calcium bicarbonate. So when water is having magnesium and calcium hydrogen carbonates or magnesium and calcium bicarbonates, so that water get temporary hardness. That water get temporary hardness. The water which is having magnesium and calcium hydrogen carbonate, that gets temporary hardness. This can be removed by simple boiling of water. Here, on boiling, calcium bicarbonate and magnesium bicarbonate are precipitated as insoluble salts, which can be removed through filtration. So when on boiling calcium bicarbonate and magnesium bicarbonate, they are precipitated out as insoluble salt. This can be removed through the filtration, simple filtration. Here, when this calcium bicarbonate heated, when the water which is having calcium bicarbonate, when it is heated, so calcium bicarbonate, when it is boiling, it will form calcium carbonate plus water plus CO2. So when magnesium bicarbonate boiling, it will give magnesium hydroxide plus carbon dioxide. Magnesium hydroxide and carbon dioxide. So this will form calcium carbonate and magnesium bicarbonate form magnesium hydroxide. Both are insoluble salts. Calcium carbonate and magnesium hydroxides are insoluble salts. So insoluble salts, these can be removed through the simple filtration. So temporary hardness is it can be removed by simple boiling, and it is due to presence of magnesium and calcium bicarbonates. So when these are on boiling, the calcium bicarbonate and magnesium bicarbonate are precipitated as insoluble salts, and these can be removed by filtration. Here, permanent hardness. So permanent hardness cannot be removed by boiling. So whereas temporary hardness is removed by boiling. Here, permanent hardness cannot be removed by boiling. It is due to calcium chloride, calcium sulfate, magnesium chloride, magnesium sulfate, and nitrates in water. So these salts cannot be removed by boiling. These salts cannot be removed by boiling. So the Fe plus 3, aluminium plus 3, Mn plus 2 also cause hardness to the water. The Fe plus 3, aluminium plus 3 and manganese plus 2 salts also cause hardness to the water. So permanent hardness cannot be removed by boiling, and it is due to presence of calcium and magnesium, chlorides and sulfides, and nitrates. So example, calcium chloride, magnesium chloride, calcium sulfate and magnesium sulfate. So due to presence of these salts in the water, so the water get permanent hardness. So the permanent hardness, it is due to the presence of calcium chloride, calcium sulfate, magnesium chloride, magnesium sulfate and nitrates in water. So these salts cannot be removed by boiling. So again, and also the Fe plus 3, aluminium plus 3, Mn plus 2 also cause hardness, permanent hardness to the water. Here, generally the hardness of water is always measured in terms of calcium carbonate equivalence. Generally, the hardness of water is always measured in terms of calcium carbonate equivalence, because hard water contains carbonates, chlorides, sulfates and sulfates of calcium and magnesium. So the hard water contains carbonates, chloride, sulfates of calcium and magnesium. So from all of them, the molecular mass of calcium carbonate is 100. So here magnesium, calcium carbonate, calcium chloride, calcium sulfate, magnesium chloride, magnesium sulfate. So among all these salts, the molecular mass of calcium carbonate is 100. The molecular mass of calcium carbonate is 100. So molecular mass of calcium carbonate is 100. So measuring hardness requires one standard value as a constant to equate with. The measuring hardness requires one standard value as a constant to equate with. Hence, the hardness of water is measured in terms of calcium carbonate, as it would be easier to equate values with respect to 100 as compared to molecular mass of other hardness causing agents. So the hardness of water is measured in terms of calcium carbonate, as it would be easier to equate values with respect to 100 as compared to molecular masses of other hardness causing salts. So the hardness of water is always measured in terms of calcium carbonate equivalence. So the formula for amount equivalent, the calcium carbonate amount of equivalent to calcium carbonate, the amount of hardness causing salt, in terms of calcium carbonate equal to amount of hardness producing salt and molecular weight of calcium carbonate and molecular weight of hardness causing salt. Here, the amount of hardness causing salt in terms of calcium carbonate equivalence equal to amount of hardness causing salt amount of hardness causing salt into molecular weight of calcium carbonate by molecular weight of hardness causing salt. Hardness causing salt. So this is the formula of amount of hardness causing salt in terms of calcium carbonate equivalents. So we have to use this formula for the calculation of amount of hardness causing salt in terms of calcium carbonates. Here units of hardness. So units of hardness is 4 parts per million. We can measure hardness of water in ppm, parts per million, milligram per liter, degree Clark. Fourth one is degree French. So 4 units are there: parts per million, milligram per liter, degree Clark and degree French. Here what is parts per million? It is parts per million. So it is denoted by ppm, parts per million. The parts per million, it is denoted by ppm. It is the number of parts of equivalents of calcium carbonate equivalents of hardness causing salt present in 1 million parts of water. It is the number of parts of equivalents of calcium carbonate hardness causing salt that is present in 1 million parts of water. So number of equivalents of hardness causing salt in terms of calcium carbonate present in 1 million parts of water. 1 million parts of water. So that is denoted by 10 to the power of 6 parts of water. 10 to the power of 6 parts of water. So the parts per million is the number of parts of equivalents of calcium hardness causing salt in terms of calcium carbonate present in 1 million parts of water. That is 10 to the power of 6 parts of water. So this is about ppm. So unit of hardness of water. Here next milligram per liter. Next is milligram per liter. So this is denoted by mg per liter. So this is denoted by mg per L. Mg per liter. Here this is number of milligrams of calcium carbonate equivalents per liter of hard water. Milligram per liter is the number of grams of calcium carbonate equivalents per liter of water. It is the number of milligrams of hardness causing salt in terms of calcium carbonate equivalents present in 1 liter of hard water. So this is milligram per liter. Here example 1 mg per liter means 1 milligram of equivalents of calcium carbonate hardness causing salt. It is present in 1 liter of hard water. So in 1 liter of hard water, so 1 milligram is present. 1 milligram of equivalents of calcium carbonate, that hardness causing salt is present in 1 liter of solution. So this is our parts per million and milligrams per liter. So next unit is degree Clark. So that is, this is denoted by degree Cl. So it is the number of grains of calcium carbonate equivalent hardness per gallon of water, or it is parts of calcium carbonate equivalent hardness per 70,000 parts of water. It is degree Clark means it is the number of grains of calcium carbonate equivalent hardness causing salt per gallon. So here this is 70,000 parts of water. 70,000 parts of water. Here degree Clark means it is the number of grains of calcium carbonate equivalents per gallon of water. So that is 70,000 parts of water. 70,000 parts of water. So this is denoted by degree Cl. This is denoted by degree Cl. Here next unit is degree French. It is denoted by degree Fr. It is denoted by degree Fr. It is the French unit and it is the number of parts of calcium carbonate equivalents of hardness causing substance in 10 to the power of 5 parts of water. So it is the French unit. It is denoted by degree Fr. Here degree Fr. So here this is the number of parts of calcium carbonate equivalents of hardness causing salt present in 10 to the power of 5 parts of water. 10 to the power of 5 parts of water. So whereas ppm means number of parts of calcium carbonate equivalents of hardness causing salt per 10 to the power of 6 10 to the power of 6 parts of water. So in case of mg per liter, a number of milligrams of hardness causing salt which is present in 1 liter solution. Here degree Clark. So number of grains of calcium carbonate equivalents of hardness causing salt per gallon. So that is 70,000 parts of water. So whereas degree French, here it is the French unit. It is number of parts of calcium carbonate equivalents of hardness causing salt. It is present in 10 to the power of 5 parts of water. 10 to the power of 5 parts of waters. Here interconversion of units is there. Here 1 ppm equal to 1 mg per liter. 1 ppm equal to 1 mg per liter equal to 0.07 degree Clark. So interconversion of 4 units is here. Here 1 ppm equal to 1 mg per liter equal to 0.07 degree Clark equal to 0.1 degree French. So another interconversion is there. Here 1 degree Clark equal to 1.43 degree French and 14.3 ppm equal to 14.3 mg per liter. So we have to use this interconversion while doing the numerical problems in water technology. Here they have given one solved problem. Here this is a sample of hard water contains the following dissolved salts per liter. So that magnesium bicarbonate 14.6 milligrams, calcium bicarbonate 16.2 milligrams, calcium chloride 11.1 milligrams, calcium sulfate 1.36 milligrams, silica 40 milligrams, turbidity 10 milligrams. So they have given a sample of hard water contains having magnesium bicarbonate, calcium chloride, calcium sulfate and silica turbidity. So we have to determine the temporary and permanent hardness and total hardness of water in ppm and degree Clark, degree French. So we have to find out the temporary, permanent and total hardness of water in ppm, degree Clark and degree French. So here they have given as a water sample which is having magnesium bicarbonate and calcium bicarbonate and calcium chloride, calcium sulfate, silica turbidity. So the permanent and temporary hardness of water, it is due to only calcium and magnesium salts. Due to the calcium and presence of calcium and magnesium salts, such as magnesium chloride, magnesium sulfate, magnesium bicarbonate, calcium chloride, calcium sulfate and calcium bicarbonate. So the hardness of water, it is due to presence of dissolved salts of calcium and magnesium, chlorides, sulfates and bicarbonates. The temporary hardness is due to presence of bicarbonates of calcium and magnesium, and permanent hardness it is due to presence of dissolved salts of calcium and magnesium chlorides and sulfates. Calcium and magnesium chlorides and sulfates. Here they have given a sample which is having magnesium bicarbonate, calcium chloride, calcium sulfate, silica and turbidity. So these four salts cause the hardness to the water, but the silica and turbidity does not cause any hardness to the water. So we have to neglect the turbidity and silica content. Amount of silica and turbidity in the problem. Here, so first we have to convert this hardness, hardness in terms of calcium carbonate equivalents. First they have given magnesium bicarbonate, so that is 14.6 milligrams. So we have a formula. So amount of hardness causing salt into molecular weight of calcium bicarbonate by molecular weight of hardness causing salt. So by using this formula, we have to find out the each and every salts in terms of calcium carbonate equivalents. Each and every hardness due to each and every salts in terms of calcium carbonate equivalents. So like for this formula, we have to use amount of hardness causing salt into 100 into amount of molecular weight of calcium carbonate and molecular weight of hardness causing salt. So for calcium bicarbonate, 16.2 into 100 by 162, we will get 10. And also for calcium carbonate, for calcium chloride, 11.1 into 100. So molecular weight of calcium chloride is 111. Here for calcium sulfate, the amount of calcium sulfate is 1.36 and the molecular weight of calcium carbonate is 100. Molecular weight of calcium sulfate is 136. So like this, we have to find out the hardness of what? Hardness of these salts, hardness due to these salts in terms of calcium carbonate equivalents. So for magnesium carbonate, we got 10 mg per liter. Here 10 mg per liter. So due to calcium chloride, we got 10 mg per liter. Here calcium sulfate 1 mg per liter. So we have bicarbonates and chloride and sulfate. So this bicarbonates, the temporary hardness, it is due to hardness due to magnesium bicarbonate and hardness due to calcium bicarbonate. So the temporary hardness is equal to hardness due to magnesium bicarbonate, and hardness due to calcium bicarbonate. So we here 10 mg per liter, here 10 mg per liter. So 10 plus 10, we will get 20 mg per liter. So but we have to find out in ppm, degree Clark and degree French. So we know that 20 mg per liter equal to 20 ppm. So 1 mg per liter equal to 1 ppm. So 20 mg per liter equal to 20 ppm. So 1 ppm equal to 0.07 degree Clark. So we have to convert into degree Clark. So we will get 1.7 degree, 1.4 degree Clark. So into 0.1 into 20, we will get in terms of degree French. So 2 degree French. So in degree Clark, we will get 1.4 degree Clark, degree French, 2 degree French. So here temporary hardness, it is 20 ppm. So permanent hardness, it is due to calcium sulfate and hardness due to calcium chloride. So due to hardness due to calcium carbonate is 10 and hardness due to calcium carbonate is 1. So total hardness is permanent hardness is 11 mg per liter. So in terms of ppm, 11 mg per liter equal to 11 mg per liter equal to 11 ppm. So for conversion of into degree Clark, 0.07 into 11, so we will get 0.77 degree Clark. So in terms of degree French, so we have to multiply with 0.1 into 11, so we will get 1.1 degree French. 1.1 degree French. This is permanent hardness. So we know the total hardness of water, it is a sum of temporary hardness and permanent hardness. It is a sum of temporary hardness and permanent hardness. So we know this temporary hardness is 20 ppm, here 20 mg per liter, and permanent hardness is 11 mg per liter. Total you will get 31 mg per liter. So equal to 31 ppm. So for conversion into degree Clark, we have to multiply with 0.07, 31, we will get 2.17 degree Clark. So for conversion into degree French, we have to multiply with 0.1, we will get 3.1 degree French. So like this, we have to calculate the temporary, permanent and total hardness of water. First, we have to convert the hardness in terms of catching carbonate. Then we have to find out the total hardness and temporary and permanent hardness. So this is about types and units of hardness of water. And thank you.
Like, share and subscribe. Hit the bell icon for more updates.